There's another one on this page. Yeah, so some
Take two.
I think it's still another.
Okay guys, if you have computers, laptops, just have it open.
Pretty good. Were you there?
Huh? Jason.
Oh yeah,
That's pretty fast.
I saw Jason.
Yeah. I can say what's on
Got spent a lot of money there. Just survive. They're all too big.
Hey, I spent half a grand.
Dude, yeah, it's my 22nd.
Yeah, that's it. That is like.
Dude, honestly, like, wait, are you 22? Or
Yeah, I'm 22.
Dude, like, I tell you what, like, you look forward to all your birthdays till you turn 21, and then after that,
That's like, it's just enough birthday.
yeah, yeah. It's just a reminder of getting older.
Yeah. I need old balls one time,
Dude, I'm gonna
No, I don't want that.
yeah, no, I actually, like, yeah, I'm gonna be 24, like, that's kind of wild. It's a little, like,
Oh, it's just like, you almost 30, like my head.
yeah, it's like 30.
Hi everyone. So let's start. So we're gonna have homework for today's session and last session discussion. So I'm gonna make it. So basically, if you know how to do today's problems, you will be able to do the homework pretty easily. And so through Drawdown and Delta Test, everything can be done in Excel. But in your exam, you have to write it on the paper. So the reason I'm saying this is because in Excel, plotting just takes one click. However, if you want to do it in exam, you have to plot it on a semi-log and Cartesian coordinates. That would be not comfortable. So the reason that I passed those Cartesian and semi-log coordinates is because we can actually plot the data in them. So is it clear? You're going to have a question in exam that you are required to plot the data in a semi-log with Cartesian coordinates. Is it clear? Okay. Who doesn't have this? Who doesn't have the coordinates? Everyone has it now? Have it?
Dude, I mean, it's not that bad. Like, I mean, same thing. I've only gone to it once.
Okay, so before I go through the problem, do you guys have any questions? So we are deep into reservoir engineering. Since we are using applications of reservoir performance equations for drawdown and buildup. So it should be pretty clear the equations. Okay, so may I ask you guys, what is the equation for pseudo-steady state? What is the famous one that you learned? What is it? Vogel? No. Okay, who else? Archie's? No. Okay, obviously I'm not asking to give the parameters and the format of the equation. Because I told you, the only thing that you have to know the equation is the Vogel equation. However, you remember the E-i function? Okay, when you talk about pseudo-steady state, you're talking about E-i function. And also you remember that, let me see if the equations are here. So, let me have the file open and then see the steps we can discuss it. So this equation. So you remember this equation when we talk about pseudo-steady state? It means E-i function. What does E-i function do is that it tells you the pressure at each point of reservoir based on reservoir characteristics and your QO or oil production. So is it clear? Do you have any question about this equation? No, I'm sorry. Unsteady state. Unsteady state. Sorry, yeah, it is unsteady state. Thank you for correcting me. So this is unsteady state. So within this unsteady state, as I said, you can get the pressure at each point within the reservoir. So what format of this equation we use it for drawdown and for buildup? Let me just answer this question. So you want the pressure at bottom hole. So you use this equation to actually predict the PWL, this equation. So P is a function of R, which is the distance from the wellbore, and T, which is time. But in drawdown and in buildup, you only have PWF for this function. Is it clear? What is drawdown test? Okay, that's correct. And why do we use it? different parameters. Yeah, different parameters. So let me put it in simple words. We let the well flow and we get information from the recorded pressure so we can know different reservoir properties. Okay? This is drawdown. What is buildup? Exactly. So we're talking about the same thing also, but this time we have let the well flow and now we shut it down. That pressure starts to build up. That's why it's called build-up test. And we think that, again, recorded pressures, you can get all information about the properties of reservoirs. You have a question?
Yeah, if you want to say what is the drawdown?
Drawdown, you let the well flow, okay? And you start it to flow and monitor it for some time, okay? So the time that should be monitored, should be between the unsteady state. Okay? So after you let it flow on the surface or on bottom hole, you record the pressure values. Okay? So for example, a guy on the well side is recording the pressure. He should write down the time and the pressure for each point and continue doing it for like, I don't know, maybe 24 hours till it is in the unsteady state. Those pressure data are the one that we actually use to get information. So,
Basically, don't believe because what's going on.
yeah, so your raw data are going to be your pressure points, okay? However, you should have some idea about your reservoir. For example, you should know the geological parameter like H. You should know the viscosity, and you should know the VO. Again, one question. So there are some parameters that are related to the reservoir, especially for the fluid. Why is it that we care so much about permeability? I don't know, viscosity, and for example, H, which is the thickness of the reservoir, aren't they important, or we just know them? The answer is, for example, for VO and mu-O, which is the viscosity, information volume factor, we can actually do another kind of testing to actually extract the oil down there, okay, and physically measure your viscosity and your VO. On the other side, okay, your H, which is the thickness of your reservoir, is usually known. And when we talk about wildcats, I mean, that's different. But usually, when the depositional environment are the same, you can give a right approximation of your reservoir because you know that formation. That's not a problem. But K, which plays an enormous role in your production, cannot be measured directly. And that's why you can get core, but cannot. So for example, even 1 inch or one foot core cannot give an approximation of your permeability for huge reservoir, like 10 acre or 100 acres. So that's why, and eventually you want to produce your well, right? So let's get more information from it, and that's how you do the drawdown test. So, question? No? So this equation is brought while you don't use it directly. This equation gives pressure at whatever point. Of course, if you put RW, it's going to give you PWF. But do you want to really solve this E-i function? So you remember the graph that you should have read it from? No. So basically, they found out that if you have RW, this E-i function can further simplify to give this form of equation. Or forget about this equation. So basically, you can say if RW is a small, or R is a small, which is the distance from the well. So if you're talking about the well, of course, it is very close to the well. The format of your E-i function can be converted to something very easy to use, which is this function. This is a logarithmic format. This function is the benchmark condition or formula that you can use for your drawdown test. Is it clear? So when we talk about this equation, okay, it is an approximation for E-i function. Okay, this log here, this log is an approximation of this E-i function when you're talking about TWF, which implies R equal RW. Okay, any question on this one? No? Okay, so let's move on. So now it's gonna be pretty much straightforward that we're gonna move on to our example to get it done. So let's do it together. I'm gonna have all the information open here so you guys can follow up, and I'm gonna explain it and go through it together. I'm gonna go through it together. Okay, any question now? No? Let's do it then. So I made also there's a file in the discussion. It's called steps for drawdown. Okay, these steps are introduced in the Excel file as copy of well testing in the lecture section by Dr. Yamadi. So I broke it down each step so we can do it actually step by step in a chronological order so you guys can understand. So there's step 1. So let me be clear. Again, your pressure data are those that you care most about. Okay, so the given information of any drawdown test are your pressure data. These data, you see here? This is given. It's always important to actually understand what is given and what is required. Yes. Yes. On lectures, go to under lectures, and a file called copy of well testing analysis.
Okay, perfect. Thank you.
You can find it. So always look for the pressure data. Okay, the pressure data are here. So basically, you have the time starting from 0.6 hours to 180. Okay, can I ask you a question? How do you know that you are within the unsteady state? I told you, you can only get use out of data or pressure data that are captured when the flow is in unsteady state. Okay, so how do you know that those data are within steady state? Does it pass? Has it passed the pseudo steady state or unsteady state or no? Okay, let me give you the answer. You don't know it. Okay? So you let it flow. You let it flow for some time, okay? Not for 10 days, of course, for some time, and now capture the pressure. I'm telling you, some of the data over here are in steady state and unsteady state, and some of them are in pseudo steady state. So here's how we're going to find out. By plotting it. Okay? The reason that you're going to be asked to draw these points is to identify the flow regime as either unsteady state or pseudo steady state by looking at your data for your plot. Okay, so what should you be expecting in a semi-log graph when your flow regime is in unsteady state? Linear? Okay, so let me explain it why. I just want to make sure that you guys know why. Okay, so the equation that originally I showed you is written over here. Okay, so then R equal RW, you're gonna have this formula, right? So it was this one initially. Okay, it is this one, right? So let's divide the log of t in this way. So you guys know how to. Okay, let me write it down. So log of A multiplied by B equal log A plus log B. You know this law? Okay? So you basically apply this. You basically apply this for this equation, okay? And separate log of t, okay, from the rest. Okay? So when you separate log of t, now you can do a little bit of rearrangement. So this term as well as these two terms, if you call it b, okay, are gonna be get out of the function, and what you'll be left is gonna be this coefficient multiplied by log of t. Okay, so in that case, you're gonna have equation form like p equal pi, so plus m multiplied by log of t plus b, which is this coefficient multiplied by these two numbers and this one. So this is where your linear equation is going to disappear based on the log of t. So that linear line that you're expecting is going to happen on a semi-log coordinates, as you see over here. Okay, is it clear? Okay. So to answer your question, as long as the data, okay, are within the straight line, you know that it is in unsteady state. So if you take a look at the data, so first of all, try to actually plot this data on your computer. So T versus PWF, if you plot it, this is going to come up. Okay? Also this one is all over. Okay? So when you plot it, it's going to be a section that is laid on a linear line in a semi-log coordinate. So here we find out that our steady state has ended. So if I zoom in this section, you don't see unsteady state anymore because it's not aligned with the trend line. That's where your pseudo-steady state has started. Again, this is something that is very important, and I mentioned it here. So you have two effects that would let your pressure data deviate from a linear line in a semi-log plot. So if you're talking about time day after your unsteady state, of course you're gonna have this downturn. And what is this? It's Wellbore storage. Okay. So don't be surprised when in exam you see data, some on the top and some on the bottom are not within the straight line. If it is on top, it means it is an initial stage of the production. It means it is because of Wellbore storage. If down here, it is because it has entered the pseudo-steady state. Let me ask this question. Do we have Wellbore storage if it was a water well? You don't know what Wellbore storage is? Okay, let's say you want to open the valve on top of the valve. Okay? So,
You like open the choke, is that your saying?
oh, the choke, yes. So when the oil flows, okay, so these oil in the wellbore have been compressed. Now that you open the choke, okay, the oil gradually comes up and comes out, so the compressibility decreases. So they start expanding. Expansion of the oil at initial time of flow is not caused because of the flow within the reservoir. It is caused because of the expansion of oil within the wellbore. Expansion of oil within the wellbore. Is it clear? Yeah. So the oil has a lot of gas. Okay. When it has gas, it's compressible. Okay. So you compress it, you close your well, and the oil is going to get compressed. Okay. Now the column of oil that you have in a shutting well is compressed. Now that you open the choke, it gradually expands, and that expansion causes the flow. This is called the wellbore storage. It's not about reservoir engineering, because at T equal exactly 0.1, for example, nothing has been flown into your reservoir. Okay. But for example, if it is water well, which has enormously small compressibility factor, you don't see that fact. I mean, you don't see that much of expansion. As soon as you open the choke, okay, the water reservoir is going to also move. Is it clear? So this is the wellbore storage. So there are information that you can actually get from the wellbore storage effect by plotting it in different coordinates and by different ways, but we don't care about it right now. Only thing that we care is this section is the straight line. Okay? So have you guys have the data open? Let's plot it. Okay? So I'm going to have it open here. So please plot it on your semi-log and on your computer. Your computer it should take 30 seconds.
Are you going to put it on file?
Yes. What is this?
Where is this file in Blackboard?
Yeah.
Where is
Okay, let me show it here. So if you go to class 5, copy of well testing analysis. Yes.
Could you change over to the equations on that stuff?
You want to go to the equation?
Like, can you put the equations on the screen?
You want it?
Yeah.
But as of right now, you don't need it. Just to make sure.
Yeah, that one.
It's like Blackboard. It's well testing. That's the discussion.
That makes sense.
Put on graphics.
بقول لك انت جبت الناس بكلين بالليل انا جبت ليه انت جبت ليه انا جبت ليه انا كنت 16
So What did?
I'm so glad I'm not playing this
They had like 6 catches, but like 25 people.
Dude,
Yeah, he had 3 receptions and 3 touchdowns.
yeah, 69 yards, 3 touchdowns.
Yeah.
I guess John Ross. Mixon.
Makes him sure.
Dude, I have Alex Collins. She's like,
I'm so pissed about that.
dude, it's weird. Like,
He said
Texans went snagging for the like anyone can sign him right now. He's like in Vegas. It's like plus 300 Steelers, like plus 400 for the Jets, and it's like plus 500 for the like
But dude, I don't know if I want to pay like $12 million a year for him. I don't know. That's so wonderful.
So like, he's good though.
No, yeah.
He's like the creme de la creme. I like him.
Yeah, where's all the
Yeah.
معلش كنت نايم امبارح لما انت رنيت لقيتك
انا اتصلت احمد واحد
على ما انا رحت احمد، انا رحت له الاول وبعدين احمد راح له بعد. انا رحت سالته على بتاع واحمد راح
قال لك 100 تمام.
احمد راح ساله على اخر على اخر سؤال.
شوف الاناقه بتاعي ده كم جاب لك
اديني 83.
انا بديني 7
انا مش عارف. ها؟
هيك
انا مش عارف اديني 83. يوم زيادة بتهزر.
انا اشوف انا اشوف وين بعد 35 بيستقبل 35
It's not important at all. It's just something. If the axis, y-axis gets into the middle of your graph, that's fine. It's not going to change anything. Just plot it. If you guys have done
It's 35. It's like 20 or 40%.
that's
I want to try a game that
What is it? Excel. Is it this one a copy of this?
doesn't want to be one of those
like, if you don't do the plotting on a paper, you're gonna feel the pain in exam. Okay, the reason I'm saying that you guys have to plot it at least once is because you don't have any grid logs and discretization in this log, for example, semi-log plot. Okay, you have to know how to properly actually discretize it. So how? So for example, this one could be 0.1, this one could be 1, this one could be 10, 100, and this is your time. This is your time, and this is going to be your pressure. So make sure that, okay, for this one, you should know, based on your range of pressure, how much of this interval should be. So one of your friends did it for 50 psi, which made sense. Okay? So in this case, you should know how to properly discretize it and how to properly actually plot it. Yes?
Can you explain how to get 50
Okay. So look at your range of data. Okay. So it starts from actually you don't have to do this. So it starts from here, 4,388 to 4,206, right? So let's see how wide the data is. So you're gonna have this value minus this value, okay, is all about, let's say, 200. Okay, so and let's get back to your plot. Okay, how many how many of these we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So we have 10, and it was like 20. We have to divide that by 20. So let me bring it up. So then this one is going to be divided by 10. Okay? So let's say it is going to be 20. If you want it to be optimized, that your data are going to be easier to be discretized, you should actually discretize each section as 20. Okay? But 50 is also okay. Let's see how much Excel put. Yeah, 50. Question?
So, like, on the test, he's gonna want accurate. What is it?
I have taken 4 classes to get for your partner.
Yeah.
Even in graduate school, they all want it.
Yeah, okay.
Just read my question.
Yeah. Yeah, oh yeah, I'm going
So I'm going to explain it. So again, guys. So when you plot data, okay, it's going to let you know what section to choose to actually get the slope, and that's the important fact. Okay. So let's move on because time is moving fast. So okay. So let's move on. Have you guys plotted at least on your computer, on the laptop? Okay. I have given you the Cartesian and semi-log coordinates. Just make sure that you do it with paper. Otherwise, you have to do an exam, and the time is going to be limited. Okay. So let's move on. So there's step 1. Okay, plotting it. When you plot it, you can visually tell which section is what. So in this section, it is in unsteady state. So do you not have to get a trend line? Or do you not have to get the slope?
Yes.
So again, if we are in Excel, okay, we can get the trend line over here. We can get the trend line. You don't have to get the trend line. You click on this one. Right click on it, add trend line. Okay? So when you add trend line, you should use logarithmic, and it's going to tell you the equation. Okay? But make sure that your data that you are getting is not, these ones are not included. That's why you see Dr. Gamari plotted the orange data different. If I delete it, you see you have different equation, but just don't. So you have the equation, and this is in the ln form. But don't we want it in logarithmic format? Right? So in order to get this number converted to log, so let's say you want to write this down as y equal log x plus something. Okay? You have to multiply this number, which is this number, multiplied by 2.303, something like that. So in this case, it's going to be logarithmic. Is it clear? Is it? Okay, so the reason I'm saying is because when you automatically, once you get the trend line on Excel, it gives you a natural log, while you want a log in basis of 10. And this is how you convert it. So if you do this, let's go to this file. Okay. So in this file, after applying, just let me zoom in. Not that much. So when you zoom in, so this equation was converted to logarithmic format, and if you multiply this by 2.303, okay, you're gonna get this slope. Okay, now you have the slope. Is it clear? If it's not, just say it. Okay?
You said it one more time, sorry.
Okay, sure. So you have a set of data,
Yeah.
okay, that you chose from the unsteady state, which are these orange dots, okay? So you get the trade line. You know how to get a trade line? You get the trade line and choose a logarithmic. So by the logarithmic, it's going to give you an equation. This equation, unlike what we want, it is in natural log format. In order to change it to log, which is going to be the same format as this over here, okay, you have to change this to log. And in order to change this, you have to multiply this number minus 29.98 to 2.30. If you multiply it, let's say it's the same. So 2.2998, so 2998 multiplied by 2.303. So it's quite the same as your slope over here. Okay? It is how you get the slope if you are doing it in Excel. But what about in exam? So what would you do if you have the data and you want to get the slope? Yeah, so you get 2 points, right? So basically in exam, it's not expected that you guys get exactly same slope. It's because someone might take these 2 points. Someone else might take these 2. Doesn't matter. But it's going to be within the acceptable range. Okay? And, yep, so as you can see,
For the slope, you should be in the region for the unsteady flow, right?
yeah, it has to be in a steady state regime. Otherwise, it's wrong. Okay?
Any points, but they should be within the range, right? It could be the last.
So let's say if I'm writing an exam, if I'm doing an exam, okay? After seeing all of this data, I just put my ruler and make a straight line. Okay? After that, for the slope, okay, I choose 4 points. And between those 4 points, I calculate the slope 3 times. So between 1 and 2, 1 and 4, 2 and 4, and for example, 1 and 2, 1 and 3. These points. And then I get an average for the slope, and I use that slope for my calculation. Does this make sense?
Can you find multiple slopes
Yeah.
and get an average?
Let me. So I have these points, okay? So this is log of t, and this is your b. So if I make this the line by Excel, it's going to be something like this. But in Excel, it's going to give you the deadline based on all the points. But you don't have that option in exam. So what you do is choose this, for example, one point that you think lays better, 4 points that lay better on your trend line. You just draw by ruler. So I choose 1 point, 2 point, 3 point, and 4 point. Okay. So I get the slope one value between points 1 and 2, M2, 2 and 3. For example, M3 between 1 and 3. So 3 points is enough. Then I get the average of the slope, which is going to be the average slope, which is going to be closest to an actual slope. Does it make sense?
The one in the class was talking about calculating one side.
That's another way. So you see he has pressure at 1 hour, right? So we have a function, okay, we have a value, and let's see. So the pressure difference for the 1 hour, okay, here, no. Okay, so here, use the 1 hour, okay, so I-27, where is I-27? Yeah. So you have the one at 1 and you have the one at 2. Okay? But you don't have this equation from the first place in exam. You see, he used the, Dr. Gamani used the trend line, which was given in the equation, to calculate the pressure at time 1 and time 2 and time 10. But do you have this equation? Do you have this equation in exam?
No, so how do you calculate the slope on a semi-long graph when I actually try
Let me go here. Or I can do here. So let's make sure that we know. Okay. So let's do it between. Let me just highlight it between this point and this one. Okay. So we're gonna have multiplied by. We're gonna have this value minus this value divided by log of 3.6 minus log of 1.2. So you see, it's very close to the right end. Make sense? Okay. Let me give you an advice for example. Okay? That I've used and I succeeded in all the courses that I've taken here, I mean all reservoir engineering classes. Always calculate the slope first and get all the information and then draw it. You see my point? So let me give it this point. So you basically have an idea that, okay, I'm going to ignore the first 3 points because they might be affected by Wellbore storage. Also, I'm going to, so my steady state starts from this one, for the 4th one. So use this, for example, 3 or 4 data and get the slope without you haven't drawn anything because it's so time consuming. After you have the slope, you can actually go ahead and calculate K, calculate S, calculate drainage area and everything. And then when you're done, you make sure that, okay, I have done all other requirements that were asked in the exam. Because plotting is just one, and it is least important, to be honest. But if you want to spend too much time on drawing and miss out on the main calculation part to get the different reservoir properties, you're going to lose a lot of points. Okay, yes.
How do we identify the Wellbore storage against the pseudo-staying non-growing?
Okay, to be in the safe side, let's look at the data over here. So you have plus 20 data, right? You have 20 data. Ignore the first 5, okay, and choose the 6, 7, 8, 9. Okay? And since you are getting the slope 3 times, as I explained it here, okay, you might get an idea, okay, if it is in the right range. This is not the right procedure, but this is going to benefit you in the exam. I've done this and I've got results, yes.
When you work calculating the log on the semi-log, you divided it by the log of what?
The log of time. Here, let me write the equation down so you guys can write it down. So M is going to be P2 minus P1 log 2 log T2 minus log T1.
And then how you switch it from length to log?
Switch what?
You said something about switching from length to natural log to
Natural log. Okay, if you're doing it in Excel, okay, if you're doing it in Excel, if you get the trend line, Excel is going to give you in natural log form. You have to convert it to log by multiplying it by 2.303.
What we exactly multiply? The 2.29?
Yes, 2 point, so 2.303. Makes sense? Okay, let's move on. So when you, okay, I'm going to bring it up here. So when you plot it, you get M. Okay, this M is from your pressure data. After you get it from pressure data, you put it in this equation. This is mu. So you get it, you put it in here, and everything else is going to be known. So what you get is your permeability. Okay, make sense? Everything else is here is known. It's going to be given by the problem. So after you get K, which is 25 millidards in this case, okay, you'll be asked to give the skin factor. Okay, so in a skin factor, okay, so this equation that you use. But now you put the pressure at time 1 because you have the slope, right? You can put it in the equation to get, okay, look at this equation. Okay, so for P equal 1, we can actually get it. So this is what I want to say. This equation, you can make it through the data. And if you have this equation, your pressure is a function of temperature, time. And using this, you can get the pressure at time equal 1 hour. After that, you have it, you can get the S by just merely putting it here. So if you are a little bit confused now because we're running out of time.
So basically, you have to get the slope and then start solving out the equations and go through the phase. But the main procedure is to get the correct slope so everything else makes sense. And always, like the thing that we have to focus on is that the slope should be
accurate.
Yeah, on unsteady.
And it's on a steady state. Yeah. So then you get the S skin factor. Then you move on to the next one. Okay. So you are asked step 4 and 5 and 6. So you are asked to estimate the time that the transient flow ends. Okay. So obviously you thought about it this way, but you want it to be accurate. Okay. In order to have it accurate, get the slope of all these points that you suspect that they are in the transient zone.